Today we are going to study about reflection of waves and standing waves in strings and columns. Before going to the topic, we must have the concept of displacement of plane progressive wave and its equation. We are already knowing if the wave is progressing along positive x direction, then it is represented by y x comma t equals to a sine kx minus omega t plus phi. And here y is the displacement, it is a function of x comma t. A is the amplitude, k is the angular wave number, omega is the angular frequency, phi is the initial phase. If you go through the diagram, the wave which is progressing along positive x direction will be represented like this. At time t equals to 0, if this is the picture, then after regular time intervals of t by 2, the wave has been progressed by certain distance. So that is why here after a time capital T, the arrow mark which is existing here, that has traveled a distance lambda. So the wave once again repeated after traveling a distance lambda and also after a time t. So this capital T is called as the time period and this lambda is called as the wavelength. And here there is a relation between wavelength lambda and angular wave number k. K equals to 2 pi by lambda. And so already I told after every distance of lambda the wave is repeated. Similarly, in terms of time, after every time period capital T the wave is repeated and angular frequency omega equals to 2 pi by capital T. So from this to what you can say omega by k equals to 2 pi by t divided by 2 pi by lambda. So 2 pi gets cancelled. So lambda by capital T. So the distance traveled per unit time. That means lambda is the distance traveled in t seconds. So lambda by t will give distance traveled in 1 second, nothing but the velocity of the wave. So v is the velocity. So omega by k equals to v. And if you take initial phase phi equals to 0, then the same equation is going to become y x comma t equals to a sine kx minus omega t. And at the place of k, if you substitute 2 pi by lambda, and at the place of omega you will substitute 2 pi by capital T. And if you take 2 pi common, then the equation becomes y equals to a sine 2 pi into x by lambda minus small t by capital T. And the same thing in the other way you can represent a sine, if you take k common here, then x only minus omega by k you are going to get into t, since phi equals to 0. So a sine k into x minus omega by k is already we are knowing it as v. So the equation becomes a sine k into x minus vt. So that is nothing but the function of x minus vt. So y x comma t you can say it as the function of x minus vt. This is the wave which is progressing along positive x direction. But one thing you have to keep in mind, if the wave is propagating along negative x direction, then the equation becomes displacement equation y x comma t equals to a sine kx plus omega t plus phi. So for the positive x direction, here you will get out of these two, one of it will be negative, and after if it is propagating along negative x direction, both will be positive, kx plus omega t. So I had already told equation for a plane progressive wave, that is the wave which is traveling continuously along the positive x direction. We can represent it with y x comma t equals to a sine kx minus omega t plus phi. And if the wave is propagating along negative x-axis, then it should be represented by y x comma t equals to a sine kx plus omega t plus phi. And in your textbook also you are having this diagram, this arrow mark you can see, and here after regular intervals of t by 4 time, the peaks of the wave, progressive wave, is represented here. The arrow mark is here. After a t by 4 time, the wave is traveled by lambda by 4 distance. After a t by 2 time, the arrow mark travels lambda by 2 distance, and here 3 lambda by 4 distance, and here the arrow mark has traveled a distance lambda. So after distance traveling lambda, once again exactly the wave is repeated here, and also the time interval between this and this is capital T. So after a time capital T also the wave is once again repeated. This is the plane progressive wave which is propagating along positive x direction. if two or more waves superpose on one another, then the resultant displacement will be given by the superposition principle. That states that the resultant displacement at any instant is equals to sum of the individual displacements. Once again I am repeating, if two or more waves superpose on one another, then the resultant displacement at any instant is equals to sum of the individual displacements. And based on this superposition principles, there are three phenomena are possible. One is standing waves, second one is beats, third one is interference. Once again I am saying, based on the superposition principle, there are three phenomena are possible: standing waves, beats and interference. Standing waves and beats we are going to study in the class 11, and interference is concerned of light waves we are going to study in the next year, that is in the class 12 is concerned. Standing waves, based on these waves, two waves, these are the three phenomena are possible. So standing waves is concerned if two waves which are moving in the opposite direction of same frequency and wavelength superpose on one another, then will give standing waves. Once again, if two waves which are of same frequency and wavelength moving in the same direction, moving in the opposite direction, superpose on one another, gives standing waves. Beats, if two waves of nearly equal frequencies moving in the same direction superposed on one another, will give beats. In the interference is concerned, if two waves of same frequency and wavelength with zero or constant phase difference moving in the same direction superpose, will give interference pattern. Okay, now our aim is mainly standing waves in strings and columns, and also before that you must know about the reflection of waves and reflection of waves at rigid boundary and also at open boundary. First of all, the rigid boundary, the reflection of waves which are going to take place will have, see here, suppose if a wave or pulse is traveling in the positive x direction and it is the rigid support, it is connected. Now if the reflection takes place, then there the wave is 180 degrees phase difference. The pulse, upward pulse, is becoming downward pulse now after the reflection at the rigid boundary. The same thing if you go for the reflection at open boundary, and suppose if the reflection is taking place at open boundary, then just imagine the wave here, that means open boundary means, suppose the string is connected to a ring rather than rigid support, it is connected to a ring, then what is going to happen? Here it is traveling along positive x direction, and after reflection, the without any phase difference, the wave or pulse is reflected back. So here there is no phase difference, and here 180 degrees phase difference. So that is why, suppose if the incident wave, you are representing it with yi equals to a sine kx minus omega t. Suppose the wave is, incident wave is traveling along positive x direction, because of that we are representing it like this. Then for the reflection at open boundary, for the reflection at closed boundary or rigid boundary, the equation is going to become a sine kx, since it is traveling along negative x direction, a sine kx plus omega t, and also 180 degrees phase difference is there, so plus pi. So once it is pi means third quadrant, sine is negative, so you can write this equation as minus a sine kx plus omega t as the reflected wave. But incident wave is same here also, but reflected wave is concerned. Reflected wave at the open boundary is concerned. You are going to represent it with y subscript r equals to a sine kx plus omega t, since it is traveling along negative x direction. So, and there is no phase difference, so that is why by r reflected wave displacement is concerned a sine kx plus omega t. And suppose if you take the superposition of wave or pulse at the rigid boundary, you can imagine here this and this overlaps, then resultant displacement is going to become 0. So that is why at the rigid boundary, whatever be the superposition of incident and reflected waves will give the 0 displacement or 0 amplitude, and those, that means node is going to take place at this rigid boundary. And at the open boundary is concerned, if these two waves superpose, both are in phase, so that is why resultant amplitude becomes maximum. So at the open boundary, whenever reflection wave, incident and reflected waves superpose, will gives you maximum amplitude position. That is, we are going to call it as antinode, and in the next topic you are going to study about it. So reflection of waves at rigid boundary and at open boundary. Rigid boundary 180 degrees phase difference, and wave is going to be just opposite direction, it starts moving. Incident wave and reflected wave is concerned. And in the open boundary reflection, the incident wave and reflected wave, there is no phase difference. So reflected is concerned a sine kx plus omega t, but the wave is going to be reflected back in the opposite direction. The superposition principle states that if two or more waves superpose on one another, then the resultant displacement at any instant is equal to the vector sum of the individual displacements. That is yx comma t equals to y1 xt plus y2 xt. And the reflection of waves, if you go through, a traveling wave which is moving in the positive x direction, that is incident wave if you are taking, then yi equals to a sine kx minus omega t. So if the reflection is taking place at the closed end, then the phase reversal takes place. That means 180 degrees phase difference is going to occur. And if the reflection is at open boundary, then there is no phase change. So that is why here, if yi is this much, then the reflected wave, the reflected at rigid boundary will be given by y subscript r x comma t equals to minus a sine kx plus omega t. And for reflection at open boundary, y subscript r x comma t equals to a sine kx plus omega t. That in the diagram you can observe it here. Here the rigid boundary and this is the open boundary. And rigid support if the reflection is closed end, that is also called as the closed end of the string. And if the pulse which is traveling in the positive x direction, after incidenting here, that is reflected back in the opposite direction. Earlier it is traveling from right to left. Now after reflection it is traveling from left to right with the phase reversal of 180 degrees. But if the reflection is taking place at the open end, then the pulse which is traveling in the positive x direction, after reflection it travels in the negative x direction but without any phase reversal. Equation for standing waves. See here, suppose if two waves superposing, if you are representing with one is y1 equals to a sine kx minus omega t, and second wave is a sine kx plus omega t. Since one wave is traveling along positive x direction and the other one is traveling along negative x direction. According to superposition principle, if these two waves superpose, then the resultant displacement y equals to y1 plus y2, sum of the individual displacements. So a sine kx minus omega t plus a sine kx plus omega t. So if you take a common, then sine A plus sine B, we can write it as 2 sine A plus B by 2 into cos A minus B by 2. So that is why A into 2 sine this plus this, you are going to get 2kx by 2 and cos this minus this. So if you want, you can write once again kx minus omega t minus kx minus omega t whole divided by 2. So here kx gets cancelled, minus 2 omega t by 2 will gives you minus omega t only. So this you can write it as 2a into sine kx into cos minus 2 omega t whole divided by 2. Nothing but 2 gets cancelled. You left with minus omega t. So cos minus theta is nothing but cos theta. So you can write the equation as 2a sine kx into cos omega t. And if you take this portion as a bracket, and this is called as the amplitude of the wave. So amplitude A equals to of the stationary wave is given by amplitude equals to, or standing waves is equals to A equals to 2a sine kx. And from this equation you can say that at certain positions amplitude is minimum, that is those positions are called as the nodes where the sine kx is going to become 0. So if the amplitude A becomes minimum and 0, when sine kx equals to 0, that is sine n into pi. Just imagine at 0 degrees, 180 degrees, 360 degrees, like that sine function is going to become 0. So what you can write, kx equals to n pi, or x equals to n into pi by k. Already you are knowing k is nothing but 2 pi by lambda. So you are going to get it, pi gets cancelled, n into lambda by 2. At these positions nodes are going to occur on where n equals to 0, 1, 2, 3, like that. So that means at x equals to 0 comma 1 substitution means lambda by 2 comma 2 into lambda by 2 is nothing but lambda, 3 into lambda by 2 is etc. At these positions amplitude of the wave is minimum, and those positions are called as the nodes, which are represented by n. And so from this what you can say, the nodes are in consecutive nodes, the distance between them is lambda by 2. The difference of these two is also lambda by 2, difference of these two also lambda by 2. So the distance between two consecutive nodes is lambda by 2. And similarly there are certain positions where the amplitude is maximum, and those positions are called as the antinodes, which we are going to represent with A. So A is maximum, amplitude is maximum equals to when sin kx equals to plus minus 1. So this is going to occur when sine odd multiples of lambda by 2. So sine 1 into lambda by 2 is also, sine 90 is 1, sine 270 is going to 3 into pi by 2, 3 into lambda by 2. Sine kx is plus minus 1 when sine 2n plus 1 into pi by 2, odd number multiples of pi by 2. So from this equation what you can say, kx equals to 2n plus 1 into pi by 2 implies x equals to 2n plus 1 into pi by 2 whole divided by k. But already k is 2 pi by lambda, So that is why the equation is going to become 2n plus 1 into pi by 2 into 2 pi by lambda means it is going to become 1 by k is lambda by 2 pi. So pi gets cancelled. So the equation is going to become 2n plus 1 into lambda by 4, where n equals to 0, 1, 2, 3, etc. At these positions of x, you are going to get the antinodes, that means maximum amplitude. So x equals to what you can write, if you substitute 0 at the place of n, that is going to become lambda by 4. Now 3 lambda by 4, 5 lambda by 4. At all these positions we are going to get the antinodes, and those positions are with the maximum amplitude are called as the antinodes, and the distance between any two consecutive antinodes is also equals to lambda by 2. So lambda by 4, 3 lambda by 4. Difference is 2 lambda by 4, nothing but lambda by 2. So the distance between any two consecutive nodes or consecutive antinodes is lambda by 2. And also one more thing, at 0 and lambda by 2 you are having the nodes at the mid of these two. That means at lambda by 4 position you are having the antinode. So the nodes and antinodes takes place alternatively.